Hello, today I will take up the lecture on tri and butyltin hydride, another reagent for metal hydride reductions. So here also hydride transfer takes place for reduction of organic substrates. So tri and butyltin hydride is we can write this way also, and C4 is 9 butyl, normal butyl, then hydride. Okay. Or you can write simply, you can write Bu3SNase. So it is available commercially, but can also be prepared in the laboratory commercially, but it can also be prepared in the laboratory by reacting. It can also be prepared in the laboratory, laboratory by reacting tin tributyl tin chloride, say tributyl tin chloride with lithium aluminum hydride. Okay, or we can use, so for example, I'm doing the reaction here. This tributyl Bu3 SnCl with lithium aluminum hydride is reduced to this one, Bu3 SnAce. Okay, so this we got like this. Simply we got high yield here. We can use tributyl tin oxide also by using lithium aluminum hydride. So it is about the preparation of tributyl tin hydride. Tributyl tin hydride is a very selective reducing agent, and it is mostly used for reducing the carbon halogen compounds to give the dehalogenated products. Okay, so I'm giving one example here. Say tributyl tin hydride when react with say alkyl halide. So in presence of some light or some initiator, so you get Bu3 SnX plus RS. Okay, so we got a dehalogenated hydrocarbon like this. So these are reactions generally. So the tributyl tin hydride is a good useful reagent for the reductive removal of or cleavage of carbon hydrogen bonds. So here use alkyl or aryl or alkynyl triple bond compounds in halides with a which are readily undergo conversion into the corresponding halogen free hydrocarbons. So here the reaction takes place. Here the reaction takes place through a free free radical mechanism. Okay. Radical mechanism. So here we need a initiator. Say like we need initiator is required. Initiator or the light is required. Okay, for this type of reactions. So for example, initiator mostly used are AIBN. AIBN is one of the initiator which use. It's called azo-bis, isobutyrolnitrile, okay, nitrile, isobutyrolnitrile. So this is one of the initiator which is used for this type of reactions for using the tributyl tin hydride. So this is the isobutyrolnitrile structure is like this. So these two CH are here, C and here, and then we have azo group here, C. These two methyl group, this is nitrile here, these methyl groups are here. So this is said to be azo-bis isobutyl. So this is called AIBN. Okay, it's a good initiator for reaction of this type of uh, butyltin hydride reactions. So let us see how the reaction takes place as a general mechanism of the reactions. So here, in presence of initiator ion. So let's see how the mechanism of the reaction takes place. So first initiator is initiator. So in the presence of light, so it is imparted to a radical. So this free radical initiator reacts with butyltin hydride with initiator radical, then it gives, so here Bu3 SN radical plus ionized. Okay, then this Bu3 SN radical reacts with this halogen halide or alkyl halides halogen compounds. So you pick up the proton here, this is pick up this one. So like this reaction takes place. I write this way, reaction this way. Let's say XR. Okay. So here this way, and this one, and this one here. So you pick up, X is pick up, this halogen is pick up, then you got this radical. Okay, free radical. Finally, these free radicals reacts with butyltin hydride. You can write this way. Butyltin hydride U3SNH plus this radical. Okay, so we pick up this one. Hydride is pick up. So it comes like this. So Bu3 SN radical plus RS. So in this way, the reaction takes place as free radical mechanism. So here is initiation, and these are propagation, and then this is a finally termination reaction. So it is about free radical mechanisms. So this is the general mechanism for reduction of alkyl halides with butyltin hydrides. So I'll give some examples here, some examples for many compounds I just said. For example, cyclohexyl bromide, where these two in presence of butyltin hydride, AIBN, is isobutylnitrile. This is acting as an initiator. So this gives this compound. Okay, so the hydrogen free, bromide free compounds. Another examples you can have this one, right here. So it's the same case. We have butyltin hydride and AIBN. Okay, we get this product. Okay, halogen free hydrocarbon. Okay, so chloride is removed like this. So you can have many types of reactions. Also you can have, say for example, if you react this, see, bromination takes place. First you will get dibromo compound there. That's why you use AIBN and then butyltin hydride. So reaction path is reduced. This one CH Br. So again, finally this also can be reduced further again. Butyltin hydride, then AIBN. So again further reduce. So you can get free hydrocarbons. Okay, hydrogen here. So like this, you can reduce. So I'll give one how the mechanism takes place for this type using this isobutylmethyl. So I'm giving some examples. Okay, now let's see how the mechanism of using this AIBN. Okay. So let's see. First, AIBN is in presence of light, undergo this to get the initiator. So let's say this AIBN, C and double bond and C is our methyl group and CN. Okay. So first, they undergo in the presence of light, undergo association to get this one like this, and this one, and like this. Okay, so it gives two of the radical CN plus nitrogen and triple bond N. Okay, so nitrogen here. So here you got this methyl groups are here, two methyl groups in. This is two of these are here. So it is two. one here, one here. So first is the initiator. So this one reacts with so let's say reacts with this compound tributyltin hydride, tributyltin hydride reacts with this, let's say this CN. Okay, just first pick up this one like this. So like, okay, so you got first we got this one is radical, and then this CN saturated this compound we got. Okay, but this again, this U3 SN reacts with this. So let's say one example here, this compound. Okay, this chloride. So here first you take this one, attack here, this one attack here, so given here. So this when you got a ring with tributyltin chloride, then you got this radical. Okay, so finally this radical pick up react with tributyltin hydride. The radical reacts with tributyltin hydride. Okay, so they like this hydride transfer, and then become this one. So here we got this product. Okay, hydrogen transfer here, then we got Pu3 SN. So here radical. So this is the mechanism of using this AIBN. So this is AIBN. So I am repeating again. AIBN first in presence of light. So I'll undergo decision to get this initiator radical. This radical reacts with butyltin hydride and pick up one hydrogen atom. So this becomes neutralized product, and you got a radical. Okay, this radical attack with the this chloride. Okay, this compound, and you got a tributyltin chloride and another free radical here. So this free radical finally pick up the hydrogen atom, and you got this radical and this finally hydrogen free compound. So this is about the reduction using tributyltin chloride. So this can be applied to not only to this carbon compound, you can apply to carbonic compounds like acid chloride also. The acid chloride, so acid chlorides are social, can also be reduced by tributyltin hydride in presence of AIBN initiator to get this type of aldehyde. Okay, aldehyde, or in some cases you may get CO ester also, ROCOR. Okay, like this also, but generally major product is aldehyde. So here mechanism almost similar with other cases. So let's say, so you can reduce this also further. You can use for the past aldehydes are obtained, and then can be further undergo reductions. So let's see first one, how mechanism of the reduction of acid chloride. Okay, let's see the how reaction takes. So the mechanism of reaction is, let's say, first let's say initiator, just like earlier cases. So first gives this radical, then this the initiator reacts with this tributyltin hydride. So you got tributyltin radical plus ionizes. Okay, this tributyltin radicals reacts with this acid chloride. So here you got this tributyltin chloride. This is a reaction mechanism almost similar like other cases. Then you got this radical, and these radicals reacts with tributyltin hydride. To pick up the proton, to pick up this hydrogen atom. So we got the aldehyde plus tributyltin radical. Okay, so this is about the reaction mechanism for reduction of this. So this reaction can this radical again, SI radical, can again react with another aldehyde molecule, say aldehyde molecule. So you can have this product can be CH2. Here also CH2 will be better reduced, but now I will take up. Okay, so here first, so this pick up this one. So you take here oxygen, then it goes like this, R C O, this radical here, attack to the oxygen, then oxygen like this, and given here. Okay, so here CO, C, H, R, like this. Okay, so they undergo further reduction. So another tryptantine hydride, so you can give final product R. I think you can see here RCO CH2R. Okay, so like this. So the product is obtained like that. So I'm repeating again. When acid chloride can be reduced to aldehyde or another product like this. So I write this. Okay, similar here mistake CH2R. Okay, so but major product is this one. So I go further reaction to get this compound. Okay, so this is the mechanism. First one is we have initiator like AIBN, then so in the presence of light, so you got a radical, initiator radical, reacts with tryptantine hydride to give this tryptantine chloride, radical, and then this radical reacts with this acyl chloride, this or acid chloride. So you got a tryptantine chloride, and then you got a acyl radical. This acyl radical react with tryptantine hydride to pick up the hydrogen atoms. You got aldehyde. So like this. This aldehyde cannot take. This radical, acyl radical cannot take with another aldehyde molecules. So react with molecules. So you got this like this. And intermediate, and finally reacts with tryptantine hydride. You got this product. Okay. So like this. Okay. So this is the product. So these are. So I'm telling that tryptantine hydride can be used for reduction of not only this carbon halides or alkyl halides, can be used for reduction of acid chloride. So another reaction application is about the dithyester. Okay, so I'll show the another reduction. Okay, so another applications about this one is sorry, I'll show another one. Okay, here reaction with dithysters or thyresters. Okay, so let's say for example R O C double bond S R prime. Okay, so let's say this one. So we can use tryptantine hydride PU3 SNase. So it can be reduced. This one can be reduced. First, so we take here. This will attack here now. So first indicate we have final product will be RS plus O C double bond O. And say R prime C double bond O S SN BU3 like this. So this is product, but this can be again reduced like this. Okay. So let's see how it comes up. So the reaction mechanism of this one, how it comes up. First one is we have this one will be reduced. This will be by initiator. Then BU3 first step is we'll give this ionized, pick up the hydrogen, and tryptantine radical got. See, this radical reacts with this tin radical, reacts with this thyresters, say RO, C-double-S, R prime here. So here attacks here, the sulfur go like this, and this move like this, and this go like that. So you got R, O, C, radical here, R prime here, and sulfur linked with S and BU3. Okay. So first we got like this, and this radical again. So this undergo, then this undergo, this again, this will go, this attack here. So one will go like this, other will go like this, and so like this. So you got writing here R radical plus double bond O C S S and BU3 R prime. Okay, so like this. So this finally this one undergo reaction with tryptantine hydride. So you let this. So you got RS and BU3 SN radical. So like this. So it can be used to give this product. Okay, so that thyresters can also be used for reduction to give the hydrocarbon by reacting with tryptantene hydride. So this is about the reactions of tryptantene hydride, another hydride transfer reaction with organic substrate. So it is generally used, so I'm repeating again, summarizing again, that tryptantene hydride is another reagent for metal hydride reductions, which is used for transfer of hydride to organic substrate. So here reaction takes place in the free radical mechanism. So we use an initiator in presence of light. So initiator we generally use our AIPN azobis, isobutyl nitride. So in the mechanism I have shown this one. So mechanism takes place. First one, initiator give the free radical, initiator then react with the tryptantene hydride to give tryptantene this radical, then tryptantene radical reacts with the organic substrate, so pick up the chloride or hydrogen, so it gives the organic substrate got radical, then got finally pick up this radical, pick up the hydrogen atom from tryptantene hydride to get the final product, and it is hydrogen free organic compounds. So it is used for mostly for removal cleavage or removal of halogens, CX heteroatom CX. So here, today is a reaction like this. So we have finished the reactions on reducing agents, reductive cleavage like this. So today, next class I will take up on oxidations. Okay. Now today I will run over here.